Welcome to this video on forming quadratic equations with new roots. Now, in the previous video, we looked at these formulae, and that's what we're going to use in this video, and we're going to use from a current quadratic to make a new quadratic with whatever roots that we kind of asked for. Now, none of this probably makes much sense at the moment. I think the easiest thing to do is to jump straight in with an example where we can explain a bit further. So here we have a question. The roots of the quadratic equation 3x squared minus x plus 6 equals 0 are alpha and beta. Form a quadratic equation with integer coefficients which has roots. So first part now, alpha squared and beta squared. So I think the first thing to do is to take our equation and divide by the coefficient of x squared. So that's going to give me x squared minus 1/3 x plus 2. So all I've done here is take the original and divide through by 3, that coefficient of x squared. Now, what I can then say is that this is going to be equal to the sum of the roots, isn't it? B over A is equal to the sum of the roots, obviously with a different sign there because we have that minus. Okay, so if you remember from previously, alpha plus beta is equal to minus B over A. That's what we're looking at here. Okay, so alpha plus beta is going to be that minus B over A, so that's just going to be 1/3, because we'll have minus 1/3. Alpha times beta, now that's going to be the product of the roots, so that's going to be C over A, which in our case is just going to be 2. Now we need alpha squared plus beta squared. Now to get the alpha squared plus beta squared, we need to think to some factorising, some expanding brackets I should say. So if I got alpha plus beta all squared and I expanded this, I'd have alpha squared plus 2 alpha beta plus beta squared. And I can rearrange this, so if I take the 2 alpha beta to the other side, I'd have alpha plus beta squared minus 2 alpha beta, and that equals alpha squared plus beta squared, which is what I'm looking for, alpha squared and beta squared. So alpha squared plus beta squared here, I'll just rewrite this the other way. Okay, now we know what alpha plus beta is 1/3. So we can substitute that one in here, and we know that alpha times beta is 2. So again, substituting that one in there. And this will give us negative 35 over 9. Okay, so that's my alpha squared plus beta squared. Now, it's worth pointing out that this is also going to be equal to minus B over A. Okay, it's that sum of the roots. Now with this, we're also going to need to find alpha times beta, where they are both squared. So alpha squared times beta squared, which is just alpha times beta then squared. So that's going to be 2 squared in our case, which is 4. And this is going to be equal to C over A, that product part. So to sum up what I'm doing here, just to make sure there's no confusion, we had our original roots and the original sum and the original product. We now need a sum and a product in terms of alpha squared and beta squared. So using this we can get the sum. Okay, so this one here is the sum. Okay, sum of the roots. And then we need alpha squared times beta squared for our product. So that's all we're doing, is creating the same as what we got here, but in terms of the alpha squared and the beta squared. Now, once we've done these steps, we can then put it into our equation. So we'd have x squared, and then we've got minus b over a, so we can see that that is 35 over 9, because obviously the minus and the minus there. And of course that's the coefficient of x plus, and then our c over a is 4, and that equals 0. And then I need it to be integer coefficient, so I multiply by the 9, and this gives me 9x squared plus 35. Sorry, just pause a second. 35x plus 36 equals 0. And there we are, complete. Nice and easy. Now let's look at part B. So in part B now we are trying to get roots in terms of 1 over alpha and 1 over beta. Okay, so I've just left a bit of information from before, but 1 over alpha plus 1 over beta for our sum. And then we've also got to work out 1 over alpha multiplied by 1 over beta for our product. Okay, so 1 over alpha plus 1 over beta. So starting off with the sum here, I'd make it one bracket, and that will give me, well, I can rewrite it actually, just make it the alpha first. Alpha plus beta over alpha times beta. Okay, so it's a single fraction. Now that we can work out, because we already got the alpha plus beta is 1/3, and alpha times beta is 2. So that is going to give me 1 over 6. Alpha, 1 over alpha times 1 over beta. Here the product is obviously just 1 alpha beta on the bottom, I should say. And so that's just 1 over 2. Nice and easy, I hope, nice and straightforward. So in terms of our equation, we've got x squared, then we've got minus b over a. Remember, this is with minus b over a, so that's going to be minus 1/6, isn't it? And this half here is c over a plus 1/2. Okay, so multiplying through by 6, the largest one there, or the lowest common multiple of the two, we get 6x squared minus x plus 3 equals 0. And that's our first one done. Let's look at another one. So before we start the next example, let's just talk about what we've used. So alpha plus beta squared we used. Does this give us alpha squared plus 2 alpha beta plus beta squared, which then we could rearrange to give us alpha squared plus beta squared, and that's alpha plus beta squared minus 2 alpha beta. Okay, very useful to help you out. Now there is another one that is quite common, and that would be using alpha plus beta cubed. Okay, so alpha plus beta cubed gives me alpha cubed, 3 alpha squared beta plus 3 alpha beta squared plus beta cubed. Okay, something you can do it by expanding brackets, you can do it by learning this. This is a, binomial expansion would help you here. So alpha cubed plus beta cubed is what I want to take out of this side. So I want to get rid of effectively these two, don't I? Okay, now I'm just going to make a little bit of room. That's better. So alpha plus beta cubed minus 3 alpha squared beta minus 3 alpha beta squared. Now here I can do a little bit of factorizing, can't I? Because we can take a 3 out of these, we can take an alpha out, we can take a beta out. So we've got our alpha plus beta cubed minus 3 alpha beta, which is nice, isn't it? And once I've taken that out, I'm left with an alpha plus a beta. Okay, remember we've taken the minus sign out here as well. And then that's obviously our alpha cubed plus beta cubed. So just write it the other way. And that will leave me this little identity, I guess, is the correct term, wouldn't it? As it's just the same on both sides. So this is something that you could certainly reproduce, or you could learn to make your life a little bit easier, you know, for these types of questions. So anyway, these are the two kind of things, one that we've just used and one that's going to come up in the next example. Now, before we go on to the next example, if you do find these videos useful, please hit the subscribe button and help me out. Obviously, you know how YouTube works, costs you nothing, but it does obviously help me out because, you know, then I get seen by more people and potentially then I'll be in a position to make more videos. So, you know, yeah, help us out as best you can. Costs you nothing. So here's our second example, very similar to the first one, but here you can see we're throwing in the cubes. So that's where we will start. Well, no we won't. We'll start with rewriting the equation first. So dividing through by 2 will give me this equation. And then of course let's write down our alpha plus beta. So alpha plus beta would have been that minus 3 over 2, which you know is your b over c for that, but we don't need that. And our alpha times beta in our case here would be minus 4, negative 4. So first we want to find some of the roots. So like we did before, in this case now, as we're looking now at alpha squared and beta, sorry, alpha cubed and beta cubed, we need to find alpha cubed plus beta cubed. So obviously I've already written this down on the previous little few seconds before this, so you know, just go back and look at it if you are jumping in now and not sure where this comes from. So 3 alpha beta, alpha plus beta there. So here we have minus 3 over 2 cubed, minus 3 times negative 4 times negative 3 over 2. Just working this out, and I get minus 117 over 8. And of course, as you remember, this is now going to be my new minus b over a, my sum. Now looking at the product of my roots, here I'm going to be alpha cubed times beta cubed. So alpha cubed, beta cubed. I don't know. Sorry, I don't know what I'm writing there. Write it as alpha beta all cubed. So that's going to be minus 3 over 2 cubed, which is still negative 27 over 8. And all I've got left to do is put it into my equation. So x squared, now it's minus b over a as you can see, but this is minus, so 117 over 8 will be positive there, x, and then minus 27 over 8, as this is my c over a. And then multiply through by 8, 8x squared plus 117x minus 27 equals 0. And that's my new quadratic equation with those roots. Now we're looking at part B, and this is what we're looking at: alpha plus beta over alpha squared and alpha plus beta over beta squared. So sum of the roots means that we need to add these together, don't we? So we're doing alpha plus beta over alpha squared plus alpha plus beta over beta squared. So making them over the same bottom value. So I would make this over obviously alpha squared beta squared, which is going to give me alpha plus beta times beta squared plus alpha plus beta times alpha squared. So let's now expand these brackets on the top. So we get alpha beta squared plus beta cubed plus alpha cubed plus alpha squared beta, and of course that's over alpha squared beta squared. So starting to come together. Hopefully you can see this, and really it just comes down to now some algebraic manipulation, because we're just trying to get everything either as an alpha plus beta or an alpha times beta. And obviously our issues here are with, we've got the beta cubed and the alpha cubed, which we've seen in the previous part. And then of course our issue here with the alpha beta squared and the alpha squared beta. So let's do this in kind of two parts. So I'm just going to rearrange first the alpha cubed plus beta cubed, and then plus, and then with these two, you know that alpha beta squared plus alpha squared beta, I could factorize out alpha and beta from each. Basically that then would leave me with alpha plus beta in the brackets, yeah? So that's going to be alpha beta alpha plus beta, like so. And that's over alpha squared plus beta squared. Alpha squared beta squared, no plus in between them there. Now, thinking about what we did, we can rewrite this one, same as we did on the previous question. And that will give us this. So alpha cubed plus beta cubed is here. See the previous question. And then, of course, this one we've got coming from here. Now, when we look at it, we've got everything in terms of either an alpha plus beta or an alpha times beta. This bottom one, I probably should just rewrite it as alpha beta squared like that, just so that everything makes perfect sense. And then after that bit, that was the bit following up there, but after that bit it's just a matter of substituting in all my values. So minus 3 over 2 cubed, minus 3 times that, minus 4 plus minus 4 times minus 3 over 2, and then on the bottom we have minus 4 squared. So the top of my fraction is 33 over 2, and that is over 16, which then leaves me with 33 over 32. Okay, that's my sum of roots, which is quite long-winded, isn't it? I would think. Hopefully that's okay and I haven't made a silly mistake. Let me know down below if I have. But that is, of course, my minus b over a. So just remember that. Now next we want to look at the product, don't we? So product of my roots. Now this one should be a little bit easier. So we are doing our alpha plus beta over alpha squared, and not plus with times in alpha plus beta over beta squared. So this one is just simply alpha plus beta squared over alpha beta all squared. Okay, just take that extra step there. Pop it here just so I can fit it in, but we've got minus 3 over 2 squared over minus 4 squared. And that gives me 9 over 64. And of course, that is my C over A. So all I've got left to do is write it down as an equation, isn't it? As my quadratic equation. So x squared minus b over a, so this is minus 33 over 32 plus 9 over 64. And obviously we're going to need to multiply through by 64. Wow, that's a not very nice one, is it? So that's going to give me 66. Oh, I missed out the x there. So 66x plus 9 equals 0. And there we have it. Okay, so hopefully you understand now what these types of questions are asking you. They're not too difficult. It's just really about a manipulation of algebra and testing those skills from you. So I don't think it's too much to do on this, but I'll give a few questions for you to have a go at, and as always I'll pop the answers at the end of the video. Just another quick reminder, if you haven't done so already, don't forget to hit the subscribe button and help me out. hopefully nothing too difficult with this one. I'm just jumping in here as I'm just anticipating a few people maybe getting confused. Just talking about this one, you know, when I add in these alpha plus beta, just get rid of your brackets, and then it leaves me with minus 1 over alpha squared and minus 1 over beta squared. So very straightforward there. And then obviously putting these two together. Now with this one, I need to expand these, but before I do, it's easier to make each one a single fraction. So here we'd have alpha cubed minus 1 over alpha squared multiplied by beta cubed minus 1 over beta squared. So all I've done is make this a single fraction here and this a single fraction here. Now that makes my life a lot easier, because now all I need to do is multiply these two together. Okay. So top one, you want to think like just double brackets, you know, alpha cubed times beta cubed. Then we're going to get minus alpha cubed minus beta cubed. And then we're going to get plus 1. And then on the bottom, alpha squared beta squared. Now, just going to pop this up here. So all I'm going to do is just a little bit of rewriting. So alpha plus beta cubed minus, and then outside open my brackets, that would give me an alpha cubed plus beta cubed minus 1 over alpha beta squared. Okay, so putting it in this form now, obviously we've got our alpha cubed plus beta cubed here, our alpha plus beta, alpha times beta there, and that's all we need, isn't it? So minus 6 cubed minus, and then it's minus 485 over 8 minus 1 over minus 6 squared. And then just jump over to your calculator. And apologies, of course it's plus 1, isn't it? Almost made that silly mistake. Minus 1 times minus 1. Very, very close there. Always worth obviously double checking your work. So 1, 2, 3, 5 over 288 there. Okay, so we've got our minus b over a and c over a. So x squared plus 433 over 144 minus 1, 2, 3, 5 over 288. And obviously 288 is double 144. So that's nice. So 288 x squared plus 866 x, missing the x there, minus equals 0. Missing so much here. Rushing, see, trying to get this video finished. So you know, and you guys probably rush in class, in exams and so on. So you do need to be careful and be aware. You might not always spot your mistakes. Okay, and that's the end of this video. So hopefully you found it useful and it's helped you out. Feel free to hit me up in the comments, like, subscribe and so on. See you soon.